let's solve this question. The force generated by this spring. So you see, this is a spring, and there is some kind of fluid here, fluid around this container, and fluid around. So there are three types of pressure number one in this pocket, pressure number two in this pocket, and pressure number three in this pocket. So these are three pressures, and you know, pressure equals to force over cross-sectional area. This you already know that. And now we have to do some now also this when this piston is lifted upward, the spring is like squeezed, is squeezed. So you have to find out what is the deflection in the spring. You know that the force due to the spring deflection, that is equal to K times delta X. So that is the a force due to the spring deflection. How far are we given with the K? The K is given is 8 kilonewtons per centimeter. So I can write down in SI system 8,000 Newton per centimeter, but centimeter is the smaller unit. I will convert it into meters by okay. Now after we understand this, now let's try to do the force balance about this piston. This is a piston, and now I'm going to draw this piston here and show you the force due to the pressure being exerted. So one pressure is coming from the bottom, so it will exert force from the bottom. Let's do the force balance rather than the pressure balance. This is a force from the bottom of the piston, and then there is a pressure here and it generates force. So I'm going to write down P2 or F2, sorry, F2. And there is another pressure due to the spring which is being deflected. It is still pushing the piston downward, so it is due to the, I would say, Fk. This is spring. K stands for like stiffness of the spring. Fk is the downward force of the spring to push this piston downward. And there is another pressure P2. I'm sorry, this is P3. This is F3, and this is F2. Now this is a force balance, so let's write down the equation balance of the forces in the y direction. All the forces, the free body diagram, all the forces, they are equals to 0 in the y direction. So in the y direction force balance, so let's assume this positive is upward. Okay, positive is upward, so I'm going to write down the equation of equilibrium for the force balances. F1 is upward, equals to F2 plus Fk plus F3. And we have to find out the deflection. This is Fk. We have to find out the deflection in the spring, and the pressures are given in each pocket. The pressures and the cross-section areas are also given to us. So how can we do this? So now we need to find out the cross-section area. It is pi by 4 d1 square. For the d1, this is all the d1. It is like a round shape. It is like a round shape. This is my d1. You see what I mean? This is my d1. So pi by 4 d1 square. So pressure P1 times area 1, and then equals to pressure P2 times area 2. And what is cross section area at location 2. This is location 2, and we need this diameter of the top portion, the top pocket. So P pi by 4 D2. Okay. And for area 3, if you take a look, cross sectional area 3 is you see this much is the pocket. Okay, let me, so you have to subtract D2 from D1 square. So I'm going to write down P, so I can write down here. I would just write down like this. You see, to make my life easy, I would just write down area 1 minus area 2. That's it. So what is this? So first of all, let's find out what is area 1. Area 1, it is pi by 4 d1 square. So you will calculate it in a bit. Let me write down this equation here. Plus k times delta x so this is the force balance equation of the equilibrium for the forces, balance forces in the y direction. And from this equation, what is missing? Everything is given. Look, P1 is given, which you can plug it in over here. P2 is given, which is 10,000. P3 is given, which is 1,000 kilopascals. And the diameter 1 and diameter 2, they are given. So everything is given. If you do the math, you should get this answer. This is the answer for this question.